In this video, I'd like to share the details of a custom MCP server I built for some of the Nium APIs on our Sandbox environment. What is MCP? Think of Model Context Protocol as a common language for communication between AI agents on different platforms or services. It is like English for the global communication between people. Now, why build an MCP server for Nium? To enable clients and prospects of Nium to connect their LLM-powered applications to Nium developer tools. For example, we support 100 currencies in 190 countries across 5 or more payout methods. Each corridor, a corridor refers to a combination of currency plus country plus payout method, has unique requirements on the data that is collected before initiating a payment. And the requirements also change from time to time based on local jurisdictions or compliance. It'll be thousands of pages of documentation with these permutations that need to be kept up to date and complex to maintain a realistic sample data for developer consumption. Using the MCP server, however, we can easily generate up-to-date sample data that makes it easily accessible. Now, I'm excited to share a short demo showcasing interaction between an MCP client and an MCP server. In this instance, the client is Claude Desktop and the server is locally hosted and running on my laptop. I will be providing instructions to the GitHub link on how to run this on your own. The MCP server can orchestrate a workflow interacting with various Nium APIs, such as managing beneficiaries, looking up requirements for creating new beneficiaries, and even being able to simulate money transfers. So let's dive right into the demo. In this, I'll walk through 4 simple examples. First, get requirements for creating a new beneficiary in a specific corridor. In this particular example, I'll just say, give me a sample payload for a beneficiary in India. We can see that the call is made to get beneficiary API. Just before I dive into that, I also want to point out, like here, you'll see the Nium MCP server is configured with Cloud Desktop, and we have a few APIs that are or tools on the MCP server, as we call it, configured and enabled on the Cloud Desktop. So going back to this example, it retrieved the schema, which is a JSON schema, as you can see here. The JSON schema is more a developer-oriented response. However, based on that response, we're now able to provide sample payloads for each of the different payout methods that are supported in India. As you can see, SWIFT, card payment, proxy using UPI, or using a local bank transfer. All of these are different possible payout methods, and we can see the realistic sample payloads for each of these methods. Next, let's do a list of beneficiaries. Now, one of my colleagues asked me, hey, can you point out, can you map all the beneficiaries that are in a account onto a world map? So I just simply gave a prompt of, can you create a world map showing where the beneficiaries are located? And as you can see in the results here, this is a very small sample size, but this can scale to thousands of beneficiaries, in the tens of thousands of beneficiaries. We can just, for demonstration purposes, here we can see how these beneficiaries are distributed across 7 countries, 6 currencies, and the details of each of them. Third, let's now go into an example where I actually initiate a money transfer. In this particular example, I'm asking to send 500 euros using local payout to a person called James Collar who lives in Germany. It's looking for James Collar, and it's not able to find James Collar on the beneficiary list. So using the schema, and the required details, it was able to populate some information on its own. And now it's asking me to provide the details. Now, since this is a Sandbox account, I just said use realistic sample data. Boom, boom. It's able to create the beneficiary using that sample data, and it got a response of the beneficiary hash ID. Now, and then initiate a money transfer. You can see that there is also a successful system reference number generated for that money transfer. Now, if you log into the portal and look at the, I've logged out here, but like you can see based on the system reference number that the money transfer was initiated and a successful system reference number generated. Let's also briefly touch on transaction retrieval. In this particular example, I am retrieving all the transactions that are available on the account. And based on the return results of those transactions, it can summarize the transactions. In this case, there are a total of 3,350 transactions across 34 pages. And you can see that the time period and some of the initial responses. Obviously, you can dissect this data in a which way, like based on specific country, failure analysis, seasonal patterns, etc. What I've shown is just scratching the surface, and the possibilities are expansive. If we are to move this to enable this server on production, we need to have add a human in the loop capability and a strong security measures to make this really a production ready MCP server and move real money. This is the first step to enabling agent and LLM interactions with Nium APIs to meet developers, PM, and other client personas where they are, to give them the ability to interact with Nium Sandbox APIs and get information such as supported corridors, payout methods, how to integrate and limits across corridors by simply prompting in an LLM. At this point, I'm publishing this as a sample server, and it's available on our GitHub repository with instructions to run on your own. As you can see, it's in our Nium Global GitHub repository under MCP Server Sandbox. I would imagine this to be hosted by Nium and become part of the MCP registry as an officially supported version in the future. I hope you have a chance to try it out and provide the feedback on additional use cases or anything else on your experience using this. Thank you.